English.
English? Okay. Okay, welcome again. My name is Christoph Mitter. I'm architect at Autoscout, and I do a very short introduction before the interesting stuff begins with my colleagues and Florian Pfeiffer. So, the agenda today is the introduction, after that introduction of our ecosystem at Autoscout. After that, use cases at Autoscout. And at last, Florian Pfeiffer from Gute Frage nicht, I don't see, about OpenTSDB. So, I give you a short introduction or overview about context in which we are operating, some numbers, and when we move on. So, Autoscout is a used car, mostly a used car platform. We have about 2.2 million car offers actually, 17 million, around about 17 million users. And most of the data we generate is about from 1 billion requests we do every month. This is real users, human users. You can see a much larger number, which is 10 billion users, or 10 billion requests. This is because we have a lot of machine-generated requests from machines and grabbers, with commercial users which try to get the most cheapest, interesting offers. So we're constantly pulling and pushing our search engine, which leads to quite a lot of data. We handle this with around 150 servers, nearly full virtualized. We are running 2,500 virtual machines on 1.2, backed up by 1.2 petabyte of storage. The web requests and every traffic we have on the front end is handled by around about 200 web servers currently, which are organized in application pools and different clusters for different use cases. For search, nearly for most of the search traffic, we have 70 Entdecker index servers, which are supported by proxy servers, which handle most of the search requests. So with this background, all this traffic generates quite a lot of data. Currently, we are mostly or only collecting data from our web servers, which is the web logs. We are historizing our article stuff or database. And and we have a second platform, which is the after-sales market, which is for funding services, inspections for your car, which also we are collecting the web logs. We plan to integrate our other platforms like mobile and new services, where we are currently experimenting with new fields of business. Yeah, and of course our analytics data, which we are collecting currently with Google Analytics and with Omniture Cyclist. So that's all I have for introduction right now. I hope you enjoy the talks. And yeah, the disclaimer, we are hiring. So that's from my side. I was asked to mention that the next user groups will be in September and October, where there are already some talks. Yeah, so I wish you a lot of fun.
So, give me a second, please.
it works. Cool. Okay, yeah. So I will start with more technical stuff. My name is Christian Schröder. I'm working at Autoscout as a database administrator. Also, I'm technically responsible for the Hadoop clusters. Yeah. So what I will talk about today is, if it ever works. What the heck? Ah, okay. Yeah, what I will talk about is first the big picture, our cluster itself, what we are running, how we run it, with what kind of setup. Also, I will say some words about Talent. Talent is some tool we use for data flows. Yeah, and I will also explain this data flows a bit more. I will say what we do with Talent, what we do with Loom, whatever. And then I will stick over to lessons learned. We learned a lot with Loom. We also learned some interesting stuff with Hive. Yeah, and we just want to share that. Okay, yeah, let's start with the big picture. Big picture means our cluster. Our cluster is running CDH4, 4.2, and we are running it on Red Hat Enterprise Linux 6.4. Our cluster is 30 physical computing nodes. Those nodes are the only thing that is physical in our cluster. Everything else is virtual. We have 3 management nodes, 2 of them running the name nodes. For name nodes, we are using name node HA with journal nodes. So we have another management node, which is our job tracker. And all these 3 together run the journal nodes for Chrome and run Zookeeper. Also, we have some Plume nodes to gather data into. We have Hive servers to make Hive accessible to applications with ODBC. And we have, sorry, something is broken here. We have job servers. Job servers are servers, let's say they are for tooling. We use it to be able to run cron jobs and even more. Yeah. So let's stick over. Let's talk about the name nodes. Name nodes, again, are fully virtualized. Currently, our name nodes are running with 4 CPU cores and 16 gig of memory. This 16 gig of memory are split into 4 gig of memory for the name node. I mean, it's quite simple. If you have a name node, you can calculate how much memory it needs. You just, as it's written there, you need 1 gig of memory per 1 million blocks. And yeah, blocks are calculated by completely size and cluster in megabyte divided by block size, and you have a number of possible blocks. So, also you should always add a bit more for sure. I mean, not every block is filling up the complete block size. So yeah, that's the main reason we are running 4 gig. Calculating, we would need, let's say, 3.5. Okay, also we have the Zookeeper failover controller running. Just give it 1 gig of memory and it will be happy. Journal nodes the same, and Zookeeper also. Our Zookeeper isn't stressed, it's just for Hive log management, and it's for the quorum from the journal nodes also a bit. So yeah. The job tracker is same situation, same amount of CPUs, same memory, just there's a job tracker running consuming 4 gig of memory and not a data node. Yeah, that's the main difference. Oh, and also it runs our Hive meter store. Yeah.
Do you take questions in between?
Yeah.
Or just have you tested the high availability job tracker? Or?
No, we stick with MapReduce version 1 and.
No, I mean the
yeah, I mean
CH43.
Isn't it in 4.2? It's not available.
No, it's in 4.3. It's
yeah, and we haven't tested it yet. We stick with 4.2. That's on our plans to do next, but yeah. Yeah, computing nodes. Computing nodes, someone has to do work. Someone has to do all the computing stuff. So we picked HP DL116 Generation 8 servers. Those servers come with 2 Xeon CPUs. They have 32 gig of memory with 24 sockets. We only plugged in 4 memory banks. We have all other memory banks are spare, so we can increase memory if we ever would need. Also, those servers has two 1 gig Ethernet interfaces. We bundled them using LACP, which is a network protocol to bundle ports. And we have 8 1 terabyte SATA disks in for the data itself. There is no RAID configured, it's just a bunch of disks. We directly attach every disk to the operating system. No RAID, we don't need it. Our main data center is split into two fire sections, and we also split our computing nodes between those two. And one fire section is one rack in Hadoop. So yeah, every block is always replicated in those fire sections. Also, later we learned, or after we buy the hardware, have HP said, hey, this is our reference hardware for Hadoop. And yeah, from our side, it's cool. It works, it's fine. And we like to spend with this more expensive hardware, as we have tools for automatic firmware upgrading, we have tools for monitoring. The new ILO4 board is able to monitor all you need. It monitors your memory banks, it monitors everything, and yeah, this is quite fine. So if you would try this with community hardware, it would work. Why not? But you would have to spend much more time. So next, our HDFS details. Again, yeah, we use 64 megabyte block sizes. We said, hey, let's lower down our block sizes. We have a lot of small files coming in. But yeah, the time has shown, no, we will increase it back to 128. I will explain that a bit later if I come to Hive, why we also say we will increase block sizes again. I mean, it's Hadoop, you can always do it. New files will be created with new block size, also will remain with old block size, everything is cool, no problem. Our replication factor is 3, yeah. And the disk layout itself, we have these 8 disks in there. We say one disk, we put the operating system on, we put all Hadoop log files on, and the 7 other ones we use for Hadoop, mounted everyone directly, give it as 7 different data points to the data node, be happy. Also, we reserved 100 gig for MapReduce on these 7 nodes, these 7 disks, which makes in sum an HDFS capacity of 188 terabyte. If you divide it by replication factor, we can store 63 gigabyte of data, a terabyte of data. And we have this 21 terabyte of immediate storage for MapReduce, which is quite cool and very important to have, as MapReduce must be able to store data anywhere if it computes. It can't keep all in memory. You need this space. You can't say no. Yeah. Some more details on MapReduce. These servers we use have 8 physical cores, no hyperthreading. So this means we can run 8 tasks. We aim for a 2-1 split for map and reduce. For our workloads, this is fine. You can also try 1.5 to 1, even 3 to 1, depends on your workload. But yeah, we are running this. And if you see there, we have I've did some simple math with the memory. We have 20 gig memory I use for Hadoop, and 12 gig memory stays spare for the operating system for file buffers, whatever you need. You can't put all of the memory into Hadoop. You know, it will always screw up if you put it in the heavy load. So, next. Talent, I talked about. Talent is open source tool. It is able to, yeah, we use it as a scheduling service for our Hadoop cluster, and also we use that data pipeline. That is not all Talent can do. It can do much more. If you don't have a scheduling service for Hadoop yet, maybe have a look at it. It's quite simpler than OSI. OSI, for example, you have to do all this XML stuff. If you stay with the web interface from Cloudera, it gets better, but still very hard. So, and Talent is quite easy. Also, Talent has the ability to directly connect to everything that has a JDBC connection. Means for us, Oracle, MySQL, and MongoDB. Also, it has an integration for Hadoop. it is able to write to HDFS directly or read from HDFS. It is able to run Hive jobs. It can has a separate interface to Scoop. It can run Hadoop and it can run big scripts. So yeah, you have a tool, you can just design your jobs and have a data, also you have a data pipeline. This data pipeline stuff I will also explain a bit later. Yeah, in my opinion it's a powerful tool, it integrates well. Just install a talent execution server on a Hadoop node, not on your computing nodes. We picked these virtual servers, configured all Hadoop tools to be able to run, and yeah, that's it. Yeah, that was our big picture, our cluster itself. I would suggest anyone has questions yet, so we can just please ask them now. No? Cool. Good. Data pipelines. Yeah, Hadoop is about data. You have to get data in there, you have to get data out there. We have different solutions for different things. First of all, we have databases. Where we have data in, we may want to archive in Hadoop or whatever we want to do with them. Just we want to have them in Hadoop too. Also, we have our main front-end applications which run on Windows as a .NET application. So we have this Internet Information Server running, creating a lot of log files. We want to have them in Hadoop. We want to be able to analyze them. Yeah, and these are other things we are currently maybe sometimes working on if we have the time. We want to be able to have Apache weblogs in there too, which is much more easier than the IIS stuff. So it's just a matter of time. It's not that we can't handle it, we don't have the time yet. Also, Windows event logs may be interesting, and having all your syslogs in there for analyzing if something went wrong on your platform. Always cool, just put it in, we can analyze it. So, the article histories, this is where I talked about talent so far. Currently, we have this 2.2 million of cars. 13% of them change daily, and we want to track these changes. We want to see what changed, we want to see how does an article change over the weeks or whatever happens to it. So, a solution is simple. We have this talent job running. This talent jobs connect to our main Oracle database and checks when did I run the last time. Let's say it runs 15 minutes ago. So it knows, okay, I have to grab the last 15 minutes. Then it creates scoop commands to connect to our main database and grab the changed articles from the Oracle and put it on HDFS. After that, it connects back to Oracle and updates the timestamp. So it's quite easy. It's done in Talent with Scoop, as it could be if, let's say, we wouldn't be able to run the job for a day. The data would be much more as if we run it every hour or whatever. So we use Scoop, and we do it not directly in Talent, which would be possible. I mean, Talent is able to write HDFS files, so why don't we can just read it with JDBC connection and store it, but we use the Scoop one just for safety.
I have another question.
Sure.
Why don't you write it directly from the application?
Why don't we write it directly from the application? Yeah, our application is this large portal with on running on .NET and on Windows servers, and
as we started at .NET time, that's not
yeah, and
maybe we will do it.
Also, we just don't want to add another blocking part which could block. We have it in Oracle, and the database knows it. We know the article was changed, we flag it, and have another thing grabbing it. So our main application doesn't need a Hadoop cluster running. If we, for what reason ever, would shut down our Hadoop cluster or something, our main portal would work, and that is something we really want. So this is a simple stuff doing in Talent. What I would like to go more deep into is FlumeNG, which we use for our IIS weblogs, and how we handled it. Yeah, we have this 200 Windows web servers there generating the log file. The log file is written to local disk. And yeah, there is a Flume NG version running on Windows, but it's not stable yet. And also, we do not want to install Java on our web front-end applications. We have no need for it, otherwise than Flume, and yeah, we don't want it. It's a decision by the guys responsible for the web servers, and it's okay. So, our solution, we have a very small tool called log2flume. It's a very small .NET application tool. It's triggered by the Windows task scheduler once per minute and looks for the current IIS log file. Then it reads the new data, send it using syslog, TCP syslog to flume ng, and then terminates. After it normally takes 10 to 15 seconds. So a minute later it starts again, reads the delta, send it to flume. All the time. Fine. Works. You should guess it works. Some more details what we get from these IIS log files. Yeah, these are events per minute. Also, we have another tool running there. Sebastian will talk about later. This is our click tracking. This works the same way. We gather the data the same way with this log2flume. Clickstream is partitioned in Hive per hours. The IIS log stuff is partitions per minute and also partitioned by application. We have these different front-end applications. We store it all in the same Hive table, and we add a partition, which application it is, every minute. So you can just say, hey, give me the complete front-end, give me everything from web services to shared services to, or you just can say, no, only this simple application. Works cool, is a good idea. You should think. I mean, it works, and but I will explain later why I'm always saying it's a good idea. There are things you have to know about, and I will talk about it later. So our main Flume setup here. It's again quite simple. We have these maybe here. We have the IIS one sitting here. It sends to the Flume node with TCP syslog, I said. Then we added two another Flume nodes and an Afro link to reduce the number of files in HDFS. If every Flume node would write directly to HDFS, we have 200 nodes streaming data in. Currently we are running 4, but we need more, and I guess we will end up with 6 or 7. And so we would have 7 files per minute partition. And we don't want this, we want to have much lower amount of files, so we aggregate them and then put it into HDFS. Yeah. So this setup in detail is a bit complex, but works. And I will hopefully show it. Yeah, we have this, let me show. Here we have our web farm. This web farm sends to the 4 forwarders. The forwarders send data to the aggregators, and then it's stored into HDFS. And now I will explain the forwarder a bit more, if PowerPoint let me. Should it ever let me? Yeah. The forwarder has 5 different sources, 5 different syslog sources running on different ports. If an event arrives on this port, we add a tag to it with an interceptor and put it all into one memory channel. This memory channel is load balanced to the both aggregators. And on the aggregator ones, sorry, this is not right. On the aggregator one, we have this Afro source sitting. This Afro source looks at this tag we added on the forwarders and put it into different file channels. And then we have this HDFS thing grabbing the data from the file channel and putting it into HDFS. Means, let's say we have to do maintenance on our HDFS, doing an upgrade or something like that. We don't have to stop Flume. It's all buffered on these both aggregators. It's buffered on disk. We currently both run 500 gigabyte disks, and that works. We can buffer it. We can buffer there, and if HDFS comes back up, Flume starts to relay the channels and put all data in. It's quite cool, and it helps us a lot. So we reduce the stress. I don't want to wake up at night to update my HDFS. So that's the main reason. We just want to have it quite simple. We want to have it maintainable, and yeah. So Flume, our setup is working. It's fault tolerant on Flume issues. Every Flume node can crash. It's okay. And it handles our normal load easily. But yeah, we have some troubles. The forwarders tend to consume a large amount of memory. Normally they run with 10, but if we have a bit of load or we had to log to Flume for a minute or something like that, it directly goes up. The reason for this is quite simple. We have this IIS logs, and IIS logs much. So you have an event size of 16K. And this blows up your memory, as if you get an event by this log, Flume always allocates a 16K of memory, even if you have a log message with 5 bytes. It would always allocate these 16K. So yeah, this just blows up nodes. We had Cloudera here 3 weeks ago or something like that, and the consultant also says, "Whoa, had never seen such large forwarders," and we had to analyze it. And I will talk about this later too. But at the current setup with this log, it's cannot be done otherwise. You can't do it. It will fail. If you lower down the memory and you have a peak and something in this chain blocks, for example, HDFS is under load, your network, whatever, it will always queue up the memory, and Flume will run out of memory. So, again, what's this? Sorry, this is a bit...
Short question.
Yeah.
Did you have a look at some other Hadoop distributions? Because when I hear the problems you have here, there might be other distributions that have solved the problem of streaming the files into...
We
file
tested
systems
Scribe some time ago, but didn't work for us. What was it? I'm not so long in this company, 1.5 years, and this was before my time.
Okay.
And we used Flume and then switched over to Flume NG with upgrading from 3DH3 to 3DH4.
Okay, so you didn't have a look at...
We didn't have a look, and yeah, Scribe is cool, but for example, Scribe means you should be Facebook. You should have 10 to 20 guys just sitting there maintaining your Scribe. Scribe is even more, I wouldn't say shitty, it's it tends to you always need this engineer sitting at it, watching at it, looking,
Okay.
and no, it's even more complex. And what other solutions you have in mind? Your question
Well,
must
maybe I know about MapR, and they support NFS. So basically your application could write logs directly into the file system, and then you can process it with any tool.
But this means 200 files per minute. 200 web servers would write into it directly.
So you mean your Flume also there's some free applications, and
It does aggregation. We
Okay, so
end
you
with,
reduce
let's say,
the-
4 files per minute.
Mhm.
If it works fine, even 2. Sometimes 4, normally 2.
Mhm.
So directly writing into HDFS, if you write small files, is a bad idea.
Yeah, well, they actually don't have HDFS. They have their own implementation of the file system, which is called MapR file system, and they got rid of exactly this problem that you're having such large block sizes, which is completely bullshit to use if you have small files. So this problem would be solved too. Then.
Okay?
Maybe you should have a look at it.
Maybe. Yeah, lessons learned. Lessons we learned about all this running Flume and running Hive with this data is, let's start with Flume. Flume. Yeah, as I said, if we have to stop log to Flume for some problem, sometimes we aren't able to start it at the same time on all servers. If you push up with 200 servers on 4 nodes. Flume sometimes can't handle it. And also sometimes we also have to say, okay, skip, just start head of log file, as it would take too long to catch up. And yeah, so we think about this a lot, and we talk to Cloudera, and yeah, currently the solution we have in mind is do it more like Flume does it all the way. I mean, putting data into Flume with syslog is not the way Flume likes it. Flume is working for streams, for concurrent ongoing streams, and does everything in batches. So a better idea would be have a service running on your web server, connecting to Flume with Swift. Swift, not Afro, as .NET has a Swift connector, but there's a .NET connector with Swift, but no Afro yet. So Swift is the one we looked at, and having the service constantly sending the data. So Flume can acknowledge if the data has put into channel and is going the way, and this would stress down the complete situation. And we think with this one we would be able to run everything fine. Also, it would get rid of this large amount of memory, as if you send a message with Swift, it's generated on the node, and you don't need the 16K memory for every message. Yeah. Also, if you ever try running Flume, keep those Flume metrics in mind. Put them into Ganglia, put them anywhere you need them. If you ever run into a problem, if you ever have to analyze it, these metrics can save. And if you don't have the metrics but directly running into a problem, at least have your Flume configured to open a JMX port, so you can connect with JConsole and look at the beans. Yeah. Also, if you're running into problems with Flume, channel sizes can be a big problem. Let's say you configure a memory channel with 1 million and you 1 million events, and then you can easily run out of memory. So look at your channel sizes, look at your batches, and if you have heavy load, maybe reduce your batch size. Not make it larger and larger and larger, reduce it. Flume can handle smaller pieces very much better than larger pieces. And yeah, in my personal opinion, there's no way to calculate these all these values. For MapReduce, for HFS, there are currently formulas. You can almost calculate everything. But for Flume, you have to try out. We didn't find another solution, and yeah, you have to try out a lot. So, Hive. Hive, I talked about these little files. One problem with Hive we had was, hey, our job's taking so long. Analyzing a day of data is not so much. I mean, we're talking about 50 gig memory compressed with these large, small files. Yeah, there's one property to get rid of this. It's this Hive Hadoop supports splittable, combinable input format. We have these text files sitting there in our partitions. They are 5, 10 megabytes. And if we start a map job, it starts, for every file, it starts an own map job. And if you set this property to true, it aggregates them on block size and then starts a map job. So for us, we stripped down our maps from thousands to hundreds. And this was 3 to 4 times faster. I mean, JVM is starting up for every map, shutting down. You could try reuse, but reuse has other issues, so yeah. Also, avoid large text files. If you have to go with text files, try to keep them at block size. If you compress them. If you have a text file sitting there with 1 gig and it's compressed, this is one mapper. It's not a good idea. And also, this is what I talked about. If your data comes from FlumeNG, solution for us at the moment is we have the table where the data comes in, near or less real time with Flume, and we aggregate data in there to another archive table. And if doing this aggregation, we switched file format. We switched from text files to RC file, which is faster. and we lower down the number of partitions. We have this very small partitions on a minute base to be able to access data fast. But later on, if data gets older, we will always access it daily. So lower down your number of partitions. Hive is very happy with low numbers of partitions. And yeah, as I said, test the files Hive support. RC file, sequence file, or RC file, which is new, shouldn't it be? Yeah. I mean, test them, see what works good for you, and what's not so good. And if you do this aggregating from a small staging table into a larger one, you could enable indexes, as you can do it with insert into override select from. Hive would gather statistics and you have an index on your data, which is also quite nice. Yeah, Impala. That's another thing we tested in the last weeks. Impala is something Cloudera developed. It sits on top of your HDFS and it is able to access the data in your HDFS, but without all this Java stuff. It's doing it with, it's running cdaemons on every node, and it's quite fast. I mean, we went down from, first we started with 5 minutes for a day, then we went down with all the optimizations to 1 day, 1 minute, and with Impala we are 200 milliseconds. It's more or less, it's cool. But Impala is a beast in memory. Impala does everything in memory. I mean, we have, as I said, we have 2 gigabyte, 12 gigabyte memory for our operating system. And I said, okay, we take 4 gig for Impala, but that allows you to analyze only small amounts of data, as every data has to fit into it. I mean, 13.4 is not so small, but yeah. And Impala, if you ever trying around with Impala, it's easy to install. It supports C groups, and C groups is supported with Red Hat 6.2, so you can limit it to, let's say, only use 3 cores, only use whatever. And Impala also includes assembler code to be very, very fast, but check if your CPU is supported for those applications. If you plan to buy new hardware, check which CPUs are supported. This assembler code can save so much time. Yeah, it's stable, so far we can test, and it's very easy to integrate. It has a JDBC connection, it has an ODBC connection, works for most every application. And yeah, for us it means we're thinking about putting more memory in our nodes, so we can just give more memory to Impala. And yeah, that's it on the Impala slide. That's all I have to say. Questions? Yes?
Have you tried or calculated the costs between cheap consumer hardware like Google is doing it and your HP stuff? I mean, have you thought about it? I mean, you save a lot of money around with your RAM, you don't need ECC RAM.
Second, please. Sebastian, kannst du mal kurz hinten rausgehen? Wegen den Gläsern, wahrscheinlich. Okay, sorry.
RAM is way cheaper, it's only log files, so...
Yeah, but you have to maintain the hardware. And you have to... I mean, we have a separate team managing the HP stuff for our virtualization platform. And they have setups, they have tools to maintain the firmware, to completely push out BIOS settings, to be same on all nodes and such like that. And so for us, it wouldn't be such a large benefit as we have to do all this again and keep in mind, and if we add another hardware, we have to check it again, it works, and so on. So we not directly calculated the cost, but in our opinion, it wasn't worth thinking about, because this DL160 Gen 8 are not so expensive. They are expensive, but not so expensive. Answered?
Is there other talk coming about what you will analyze?
Yeah, we have a talk showing more data, doing some stuff we do with Mahout, and also a talk showing some stuff with Hive, and so yeah. Okay?
Do you somehow compress your data?
Jesus. Didn't I say it? We tested Snappy, gzip and bzip, and gzip works perfect.
Okay.
We just created the table 3 times with different compensation and then did a lot of benchmark. I would always suggest benchmark your data. Learn your data. Learn it, understand it, and then you can get the most performance. So, who were first?
The tests with Hive for the performance test, did you do that with the new Hive, the Stinger initiative, or
We did
there's
it
an
with
optimized Hive version? So I was wondering if you did the 2 numbers, the performance numbers for Hive, one 5 minute, one 1 minute,
Yeah.
and is the 1 minute Hive, is that, what is optimized about it?
Mostly it was optimization with combining the text files.
Oh.
And that would get, combining the text files was at 2 minutes, and then switching file format was going to 1 minute.
And also, there's another question, could you also explain a bit more about how do you manage your clusters? Puppet, Chef?
Puppet. We have a self-written Puppet module for CDH4, which integrates in our normal Puppet infrastructure, as we have Red Hat Satellite running there, so you can't just subscribe to the repository as you do it the normal way. You have to do some tricks and workarounds. So yeah, we have Puppet, and Puppet
Which
is
version of Puppet are you using?
3.1 at the moment. Planning to upgrade soon, maybe. Yes?
What was the reason to do this with Hadoop? I don't see anything special. This could be done with a relational database also.
What was the reason to do it with Hadoop? We want to store much more data. I mean, we have talked about the web logs. This means 50 gigabytes per day. Yes, this can be done with a normal database. For which cost is the first question. And
Well, there is, for example, Postgres or, I don't know, there are open source projects too.
yeah, but if you put 50 gigabyte compressed data in there, it would be very difficult to have it for 2 years or longer. In my opinion, it would be difficult. Yes?
You said that you have a replication factor of 3.
Yeah.
And I'm wondering if it happens often that machines fail, and if that happens, what's the most common reason for that? Is it hardware failure, or is it just a virtual machine crashing?
You try, and the replication failure is for replication factor is for 2 things. Replication factor once is for failure if a data node fails, and the other reason you may want to increase it even for some files is you spread it about your clusters. So if you have, let's say you have a file with 1 gig, split it in with normal replication, normal block size of 128 megabytes, so you would have 9 files lying, 9 blocks lying around on your cluster, and every block is replicated 3 times. So the data is spread over your cluster, and you could use all your hardware to analyze it. If you would have lying it on 1 node, only 1 node can analyze it. Map reduce means bring the code to the data. So you have to spread the data to run the code multiple times. Okay? Yes?
Is this IIS log file is a standard text file? Is this 1 line with the
It's-
timestamp and
Yeah, it's Microsoft calls it W3C format. It's just containing like Apache weblog. A bit more information, as also cookie is written in, so it's not the standard combinable format from Apache, if you know that a bit better. It has much more information in, but yeah, it's a normal text file, 1 line meets 1 request.
if you try to convert this standard file in an optimized binary format, like date, you don't need the date as a string, you can store it binary, or you lose the year, you know what year it is.
No, we didn't try to launch that. We just put it in and analyze it as it works, and we didn't try to launch this. What we do is doing it in this RC file, which means it's already splitted by columns, but not binary-wise splitted.
And do you filter, do you store the whole file with every request on every GIF or image and page, or
Our content delivery servers, which provide images, are currently not streamed into Hadoop, but everything else is streamed into. And yeah, and with this Flume setup, you can't say data from one file ends in one file. Data from 200 files end in one file and is combined. I mean, Flume gets in from the forwarders, comes to the both aggregators, and both aggregators writes in. So what could happen is you send one web server sends his delta to a forwarder, and forwarder has this load balancing in to fill both aggregators. So the file could be split there and be on two different files in HDFS, which is okay for us as we just analyze it with Hive. And Hive always reads all files.
Did you buy the support subscription from Cloudera?
No.
You didn't?
We didn't, no. But we don't need it at the moment. But they changed things recently, so you can, I guess it was run unlimited nodes with this Cloudera standard. And we had a look at this Cloudera manager. It looks cool. Everything it does can be done manually. We do almost everything it does with Puppet and Gunlia, but it also has some features. Even if you are new to Hadoop and want to start with it, look at it. It's cool. But yeah, if you have existing clusters, I don't see a reason to switch.
So you just have Cloudera guys popping in for consulting?
Yeah, we had them in to review our cluster and say if we have did some large mistakes or whatever. And yeah, they found some no large mistakes. It was the amazing thing. They found this splittable stuff. This was one of the things they found, and also they found some MapReduce and HDFS values we could optimize a bit. For example, how many parallel copies and so on.
Could you share more of those?
When I'm done with my cluster review, I may add another performance optimization talk to one of the user groups, but will take time because this is many, and I mean it's a very deep dive if we do this. So I'm not sure about the Hadoop knowledge in the audience. So I guess for many people it would be just too deep. I mean, I stripped it out here.
But you are in production now, right?
Yeah.
For
We
how long?
have how long? 2 years?
2 years.
With the new setup since about 3 months.
Yeah, new setup with CH4, 3 months, and old cluster.
Are you happy with it? So can you sleep at night or?
Yeah.
Okay. Because you said earlier that you don't
Yeah,
want to woke up. So
but we
that's
plan
running smoothly.
everything so we can sleep at night.
Okay, so it's running
That's
smoothly. for
One
you.
of the most important things for us.
Yeah.
Okay. Yes.
Are you storing or have you plans to store some valuable data inside you don't want to lose or something?
We don't want to lose our web logs, for example. It's a very important thing for us. You can, I mean, it's not that it's just web logs. You can get so much data from your web logs, and it's important. And you won't be able to say how did the user behavior change within a year. So for us, it is important data. Also, this article history is important for us.
Handling as a valuable everything and
Not everything, but yeah, this both I talked about, I would say, yeah.
and this architecture is enough, you don't need to create another kind of backup system or whatever.
We have no backup yet, and creating a backup for Hadoop mostly means set up a second cluster and create do this CP.
You can backup also input data. The data coming in you can backup.
Yeah, but the amount again. I mean, where to put and writing 50 gigs on tape is okay for web logs. I mean, we have more, and it will be more and more and more. So backups. If I would ever ask to back up a Hadoop cluster, I would say create a second cluster. Get a Hadoop DistCP job running every 50 minutes or something like that. It can just incremental, so you have your backup.
Have you ever lost data then? Have you ever lost data so that you would need a backup?
On our old cluster, we once lost a bit of data, but it was only in /10.
You did reboot a server, yeah?
Yeah, something like that. Let's say name node should always have enough memory.
Okay.
Okay.
This is for replication to another data center. Yeah?
No, this is in one. This is one data center, but two different file sections.
This is current solution. And what do you?
If we would ever go to
Recommend it
another
to
data
have a-
center, I would do this CP stuff.
Yeah.
It's not a good idea to spread your cluster between data centers. Normally, if you have dark fiber between your data centers, then maybe, but normally you don't want to split your cluster between data centers. So, anyone else?
Maybe a last question.
Yeah,
because we
I
have
would
2
also
minutes
say
more,
last
so-
question. I reached my 45 minutes.
So do you keep Hive, or do you really drop Hive and only use Impala?
No, we will keep Hive. Impala, even if we add these large amount of memory. And I calculated it once, and I end up, even then, we would be able to handle 2 months of data in Impala. And then all our memory would be gone, as it has to store the uncompressed data. And text files, web logs compressed, so let's say 15 gig means you have 150 to 200 gig of data and per day. So Impala would sometimes run out of memory. They do a lot of stuff in there with these hash mappings, and we can talk about this after the talk. But no, we will stick with Hive for really long time analysis. So, done. I would suggest we will do the second talk. Just if you want to grab some food now, and then we will do the second talk within the next 5 minutes. And after that talk, we will have a short break, and then we will start the talk from